Question 6. Another form of the quadratic equation. First one, I want to expand this first. And then I change the position of the term to get the formula of the quadratic equation. And then I will divide both of them. That's quite difficult, so I have to solve that by my hand. Okay, the delta will be equal to 42 square minus 4a and c. Okay, 42 times with 42, 4, 8, 8, 6, 1, 4, 6, 7, 1, 1, 7, 64, and 36, 49, 4, 27, 3 here, 4 here, 2, 4, 1, 4, 6, 7, 1. Oh, so is 0. So because delta equal to 0, it means you got the h1 will be equal to h2 and equal the formula of the minus b over 2a. This means minus b 42 divided by 2a is mean 2a. And divide all of them by 2 first. And divide all of them by 3. 7 over 3. So h1 will be equal to h2 is 7 over 3 with the value of the question A. Question B, the rational expression. So the first one I want to move it all of them in one side. And the common denominator is y plus 1. It means I change 1 becomes the y plus 1 over y plus 1 and minus 2y times the y plus 1 and over y plus 1. So all three terms have the same denominator in y plus 1, so I just put the operation of the numerator only. 2 plus y plus 1 minus 2y y plus 1 equal to 0 over y plus 1. The y plus 1 in the denominator will remind you about the domain of this function. The domain of this function have to which the value of y, the denominator cannot be equal to 0, so y have to be different with minus 1. So from this one I will skip the denominator because the denominator can be equal to 0. So the rational expression equal to 0 is means the numerator have to be equal to 0. So 2 plus y plus 1 minus 2y squared minus 2y equal to 0. So change all this term, you come to the right hand side to take the highest degree have to be the positive number. This means the 2y here plus with y and minus 3 equal to 0. So using delta to solve this equation, and after you finish you will find that y have to be equal to 1 and y equal to minus 3 over 2. Okay, you can using the delta. Let me check when y equal to 1, so the function will be equal to 0. Yes, y equal to minus 3 over 2, minus 3 over 2. Yes, it also gives the final result equal to 0 of the function. Okay. Question 7. Solve the simultaneous equation. This simultaneous equation includes the two equations. The first one is a linear equation, and the second one equal to the quadratic equation. So the best way when I teach you about the system equation, I recommend you using the substitution method only. So from the first linear equation, you will take the one value for substitution method. It means I will take the x here and y minus 3. So I substitute the y minus 3 for all the x place. It means 3 times with the y minus 3 square minus 2 y minus 3 plus y square minus 17 equal to 6 equal to 0. So the first here you will get the y square minus 6y plus 9 minus 2y square plus 6y plus y square equal to 17 equal to 0. So 3y square minus 18y plus 27. So simplify the second degree first. You will get here is the 2y square and minus 12y, and the constant number is 10. Yeah, this function is quite easy to solve. Again, using the quadratic equation formula, you will find delta, and from delta you will get the h1 and h2. So after you finish all of them, you will get the value of h1 very easy, equal to 1, and the h2 will be equal to 5. Okay. Question 8. Find the value of h such that h power to 3 over 2 equal to 64. So again, I will change the 64 equal to the base number with the value of h is which number I have here is 3 over 2. Okay, sorry. Another way you have to solve this one. If you want the value of h, it means you have to find the h power to 1. So 1 change from h power to 3 over 2 equal to h power to 1. It means you have to take the power number outside is the 2 over 3. 2 over 3 here, it means you have to take the power to 2 over 3 both sides. So it means h will be equal to square root of the 64, and all of them will be square. Cube root of 64, sorry. Cube root of 64, it means 4 square, it means the 16. So the value of h equal to 16. Given that, question B, find the value of the rational constant a and b. From the rational number in here, you have the denominator is an integer number. So I have to change this become to the integer number in the denominator. So I want you to review about my power number and conjunction video. Yes, I have this video in this playlist about the Happymath channel. So I have to time the rational number equal to conjunction. Conjunction is mean I have to time with the 2 square root of 3 plus 3, not minus anymore. This rational equal to 1, so the expression will be unchanged. So from this one, I will take it. It will be equal to 2 times 3 plus 3 square root of 3 plus 2 square root of 3 and plus 3 and 2 square root of 3 square minus 3 square. So this one will be equal to 5 square root of 3 and plus with 9. And this is 4 into 12 minus 9 and 3 here, 9 here and 3 here. Rational constant a and b. So from this one we get 5 over 3 square root of 3 and 3. Okay, let's check. Oh. 3, 6, 6 plus 3, 9. Okay, this is right. Question 9. The point P lies within the circle, the radius 3, center. If you got the radius of 3 and you got the center is 2 and 4, so the radius of the circle is 3. So point within is mean the distance between the center and the point will be less than the radius. So that's why the point lies within the circle. Within the circle. So the first one I want to check the formula of the distance and the radius in the center. We call the center is C and the point here is K. So the formula to calculate of the distance between the P and C is 2K minus 2 square plus with K minus 4 square will be equal to something and have to be less than the radius, it means the less than 3. So from this inequality I want to square both sides of this one, and it is 4k square when you expand, and this is 8k plus 4 plus k square minus 8k plus with 16 minus 9 less than 0. So the k here is 5k square minus 16k and minus 5 less than 0. Oh sorry, I forgot the 16 here. So 4 plus 16, 20 minus 9 plus 11 plus 11. So this is the quadratic inequality. So the quadratic inequality, first one you have to find the value of k for this function has to be equal to 0 first. So when you use the delta and you will find that the k1 equal to 1 and k2 will be equal to 11 over 5. And then you want to find the value of k to this function less than 0. So I will draw a k-axis. This one is the 1 and this value is the 11 over 5. The value of k is the value of a in this quadratic equation is a equal to 5 greater than 0. So it is plus, it is a minus, it is a plus. Less than 0, so it means I have to take the within interval of the 1 and 11 over 5. So the value of k will be 1 less than k and less than 11 over 5. So this is the solution of question B.